So we have 12 centimeters plus 14 centimeters plus 12 centimeters plus 14 centimeters is equal to 52 centimeters. Now, each centimeter represents 50 meters on this map. So for every 1 centimeter, it equals, so I'm going to go, oops, 52 centimeters, right? So my ratio is 1 centimeter represents 50 meters, but because I want meters, I put them on top and centimeters on the bottom, so they cancel. So you're right, 52 by 50, and what does that equal?
That wouldn't be right. Centimeters to meters, 50.
Because it's 1 centimeter on the
It
map.
gives you a scale right here on,
Oh yeah,
on the question. So what did you get?
2,600.
2,600? Do we agree?
Yeah.
Meters? But it asks, the question asks, how many kilometers? So what's my ratio of kilometers to meters?
1,000 meters in 1 kilometer.
There's 1,000 meters in 1 kilometer, so 1 kilometer has 1,000 meters. So I divide 2,600, and what do I end up with? 2.6 kilometers. So far, pretty easy, straightforward. Okay. Notice every time I do a conversion, I stack them. All right, that's a force of habit, but that's what I do in physics. That's what I do in higher level math. I like to stack them. I like to see my ratios. I like to see what I'm canceling out. And it's easy then. I just know that I have to multiply anything on the top and divide by anything on the bottom. Here, these are all on top. I multiply them. This is on the bottom, so I divide by it. Just makes it simple. It makes life simple. Even though you can do some of this in your head, it makes life simple if you continue to do it, especially if you get tougher questions where you got to change. I don't know what the person's name is. Anyway, she installs underground wire for invisible homes for pets. The wire is sold by the foot. How many feet of wire would she need for the perimeter of this lot? Okay. So I have 20 yards plus 37 feet. All right, and it says, how many feet of wire will she need? So what do I have to change up here then?
50 yards.
Okay, so now, we're pretty gifted at what we're doing right now. How many feet are in a yard?
3.
3. So 20 times 3 is?
16.
So I don't need to write it out sometimes. And 16 times 3?
48.
Thank you. And I add those together, and what do I end up with? Plus 74.
182.
Does that look right? Yeah? Am I checking my math? You should. Because you never know. It's been a long day. Is it okay? Yeah. All right. Example 2. Jeff designs jewelry. He has 6.5 inches of gold wire for a triangular pendant. If he makes the base 1 3/4 inches and uses all the gold wire to go around the pendant, how long will the other 2 sides be? Okay. So, first of all, I want to ask you something, just to see what your knowledge is. When I put lines like that on there, I didn't ask in the last question, so what do the lines mean? They're equal, right? They're equal, okay? And it says that the base here is 1 3/4 inches. And he has how much?
6.5.
6.5 inches of wire. So I need 6.5. I've got to subtract 1 3/4. And then what do I have to do after that? Divide by 2. Because that's going to tell me how much I have left, correct? Okay. So how do I go about this? No calculators used. How do I go about subtracting?
Make sure the denominators are the same.
Make them improper.
Make them improper, and then
Change the.
Change the denominator, that's right. So this is 13 over 2 minus 7 over 4. Okay, what's the common denominator?
2.
4.
4, I mean.
4, so I times that by
2.
and that
2.
26 over 4.
6 over 4 minus 7 over 4,
19 quarters.
19 over 4.
4.
Or
4.
4, 4, 3 quarters.
Or 5.
Okay, so how much, so what I gotta remember to do? Is,
Multiply by the reciprocal.
say it again?
Multiply by the reciprocal.
Okay, yeah, all right, now, here's the thing. This is how much this and this is, correct? So I need to find out what each side length is. So I have to divide this number by 2. Now, I like what you said. Because I'm dividing fractions, I would multiply by the reciprocal. But what I like to explain, though, is if it's 19 over 4 divided by 2, what am I going to multiply it by? What's the same as dividing by 2? Timesing by what?
Half.
A half. That's exactly right, which is the reciprocal. Right? But I like to use that, especially when I'm working with fractions, is multiply by that value as a fraction, because it makes my math a little bit easier. All right? When I sometimes put this on a paper for somebody, they really stumble with it, because then they don't know what to do with that 2. But if I say, well, then don't divide by 2, times by a half. Now you know to multiply across the top and multiply across the bottom. So what is the length of one of those sides then?
2 3/8.
2 3/8 of an inch. All right? So far, so good?
Yeah.
Has anybody started page 80?
Yeah.
You have? You got it?
Up to 81, but we don't know how to do 5. Yeah.
Okay, so I'm going to give you an example. You can pick whatever side lengths you want. The total has to be what? 24. So give me 2 side lengths which I would add to get to 24.
Well, 6
For me? Remember I got 4 sides, right?
6, 6, and 6.
Yes.
What if you do? Or no, these are rectangles.
What'd you say?
8 and 4.
8 and 4? Sure. So let's do this, and like this, correct? So the width, 8 yards by 4 yards, correct? And then it says, okay, well, what's the area? The area for this would be 32 yards square, right? Correct? So what it wants you to do is pick another set. Here, girls.
Oh, okay.
Pick another set of side lengths and do the same thing and see which one gives you the maximum area when it's all said and done.
Oh,
Okay?
so we can do pretty much anything,
Right.
right?
So you can use 10, 10, 1, 1, or sorry, 2, 2, I mean. You can use whatever you want. So that's how you fill the chart in. Find 3 or 4 of them and find out which one's going to give you the largest area when you're done with that. Okay? All right. There's quite a few questions tomorrow on the assignment on circles. So I want to look at circles right now. And that is on page 82. We have talked about this already. I have given you a sheet. The circumference of a circle is also known as the perimeter of the circle. That's the distance around the circle. We all agree?
Yeah.
Okay, and how do I find that circumference of the circle?
Diameter by 5.
5 times the square.
Pi times d, if I'm given it as diameter, or 2 pi r, because twice the radius gives you your diameter. So whichever one you're given, if you're given the diameter, then times it by pi. If you're given the radius, times it by 2 pi. Make sense? Simon works for the city water department. He is ordering the liner for a new overflow tunnel at the pumping station. If the radius of the tunnel is 12 feet, what should be the circumference of the tunnel liner? So the radius is 12 feet. So he wants to know what the circumference of this is. Now, they asked you to find the diameter. I don't need the diameter, do I?
No.
No. And this is a calculator question because of the pi button. So I go 2 times 12 times pi. So find that on your calculator, and what do we get?
75.398.
75.398.
398.
I like that right there just as it is. Okay? Now, if I ask you what the area is, I don't know if there are any area questions. I see all circumference on the assignment. But if I ask you what the area is, how do I find the area of this circle?
Radius.
Pi times
Radius
squared. So pi times 12 squared. So 144 times pi, which gives you, this calculator,
452.389.
389?
Yeah.
Thanks, Gordon. Thanks, Josiah. And then that would give me feet squared. Sorry?
I have to find the pi.
Didn't we show you this the other day? Shift, that button there, and that button right there.
So you gotta press another button, because I pressed it, like this button and this one, and then I times it and it doesn't work.
Press those times 12 squared equals. Yours gives you 144 pi. Hit the SD button and it gives it. Okay, how are we doing? We okay? It's not, I don't think it's very difficult work for you. I think you guys are probably quite confident in what you're doing here. The stone center of the major bill medicine wheel has a circumference of 28 meters. So, my circumference is 28 meters. The outer wheel has a circumference of 85 meters.
Why is it?
About how long are the spokes? So if you're looking at your diagram, I have two circles. There and there. And my spokes go from here to here, right? On this wheel. Okay? So somebody help me with the question here and tell me, how do I find the length of the spoke from here to here?
Find out.
Harley.
You do the circumference divided by pi and then you get your answer.
Okay?
And then you subtract
Yeah.
the circumference from the small circle.
All right, you're on the right track there. There is a subtraction in here, isn't there? Right? So if I look at this, here's the center of my circle, agreed?
Yeah.
So from here to here, I'm going to have a radius. I'll call that radius 1. You agree with that? Okay? And from here to here would be what we would refer to as radius 2. So I want to know this distance from right here to right here. That's the distance I want to find. So I'm going to take my radius 1, which is my larger radius, and I'm going to subtract my radius 2. We okay? So it's a little bit of ingenuity here to understand that if I want to find that small piece on there, I have to take the longer piece, subtract the shorter piece, right? Okay, so let's find out what radius 1 is. 85 centimeters equals pi times radius 1. So how do I get radius 1 by itself? Divide. Right, so let's take 85 and divide by pi and give it to me in 3 decimal places.
27.056.
0.56. Very good. Okay, and are we talking centimeters here or meters? Meters, right? Okay, now I need the smaller one. And I do the exact same thing, except this time I'm taking 28 divided by pi. So what's 28 divided by pi?
8.912.
8.912.
1-3.
1.3 if we round it. Okay. So what have I just found? Well, R1 is this distance from here to here. Correct?
Yeah.
That's the big radius. R2 is that distance right there. And what am I looking for? I'm looking for the distance from here to here. So I take 27.056 and I subtract it. So it's not a radius any longer, it's the length of a spoke. What do you get?
18.140. It's pretty simple.
All right? How are we doing with that?
Good.
We're okay? There's quite a few questions on that tomorrow, on the circumferences. All right? So, designing a floor plan. If you want to play around with the floor plan, Jeff is an interior designer. He's designing a floor plan for a rectangular room. On his floor plan, 1 centimeter represents 1 foot. You're going to do a rectangular bedroom, include at least 4 pieces of furniture, include at least 1 circular piece of furniture. So, if you are done today, that might be a hand-in project for 85, page 85 possibly. So you've got, you can, for me,
Showing us like.
oh, at the very back, as to a way you could do it.
Yeah.
What's that? Right at the very last page. Oh, so somebody did that. Okay, you can do your own. Okay, now, I would like you to finish to the end of 84 today. And if you are done that, then you can play around with your floor plan to the end of 84. No, I just want you to do this, play around with this a little bit today. Okay, do some ideas. Put some ideas down. You'll have to know how big your furniture is. All right, how much floor space it's going to take. Okay. And I mean, if you're comfortable with your floor plan, then you can do your chapter test. All right.